Welcome back. Today we're going to go ahead and solve two-step inequalities. Our content objective is students will be able to solve two-step inequalities and check their solutions. Language objective is students will be able to write or verbally state the mathematical properties used, so justifying when solving. Why am I learning this? Well, it's important for real-world problems like helping you decide how many tickets you have to sell for a club to break even. So first, let's just go over some background knowledge. We need to understand when it's a less than or greater than symbol, it's going to be an open circle. And if it's less than or equal to or greater than or equal to, this is going to be a closed circle. So an example like this, x is less than or equal to -1. You could think of it as, okay, starting with -1, starting at -1, we're going to go ahead and first start with an open circle. And since it's less than, we're going to go to the left. But because it's equal to, we're going to go ahead and fill that in. So for number 2, x is greater than 4. So first you're just going to start with an open circle at 4. Since it's greater than, we're going to go ahead and go to the right this time. And because it's not equal to, we are going to go ahead and leave it open. Okay, so generally speaking, if you're going to see this equal to symbol, you would go ahead and fill it in. So find 3 solutions for the following inequality. Basically, 3 numbers that, when substituted in for x, will also create a true statement. So x plus 3 is greater than 5. What could x be to make this a true statement? Now, hopefully you understand that there are a lot of answers. So one example might be 1, because if x is 1, x1 plus 3 is greater than 5. What else could I use? X can be 0. 0 plus 3 is also greater than 5. Now notice I cannot use 2, because if 2 plus 3, it's not going to be greater than 5. It would be equal to 5. So because I can't do any other number larger than 1, I would have to do -1. -1 plus 3 is greater than 5. So those are some examples. In fact, you're going to find that there are infinitely many. If you keep continuing to use negative numbers, this will continue to be true. Now, can you also think of values for x that are not true, that would not create a true statement for this inequality? I can give you one. For example, if I chose 2, 2 plus 3 is not greater than 5 because it's equal to 5. I could also do 3 plus x could be 3, and this would not be greater than 6, and so on. So here, we're going to solve the inequalities and then graph it. So what we're going to do now is we're going to treat it as if it was an equation. We're going to go ahead and get rid of this -5 by using the additive inverse, which is to add 5 to both sides. Now, why are we using the additive inverse? Because we want to create a 0. By creating this 0, I've isolated x. So x is going to be less than, here there's more negatives. How many more negatives? There's 2 more negatives. So x is less than -2. So basically, in order to graph this, I'm going to first start with an open circle at -2. Because it's less than, I'm going to go ahead and go to the left. Because it doesn't say equal to, I'm not going to fill it in. I'm just going to leave it at that. So what you need to understand is this is representing that any number less than -2 is going to be a value for x. That's going to include fractional values, decimal values. Now, you also need to understand it's not going to include -2, and that's why it's remaining an open circle. If it included 2, we would go ahead and fill it in. Now for number 2, let's try this again. I'm going to go ahead and use the additive inverse of +4 so I can isolate the x, so I'm going to have to subtract 4 from both sides. Why am I doing that? Because I want to create a 0. So this is going to create a 0, leaving me with x is greater than or equal to, here there are more positives. How many more positives? There's 1 more positive. So to graph this, I'm going to go ahead and first start with an open circle at 1. Because it's greater than, I'm going to go ahead and draw a line towards the right. Notice I am drawing an arrow to indicate that it goes on forever, it doesn't stop. But because it's equal to, I'm also going to fill it in. And there you have it. So again, you're going to have to understand that this represents any value greater than 1 will make a true statement. Again, that's going to include fractional values and decimal values. So 1.1 would work, 1.5 would work, etc. So now, number 3, very similar, except it looks slightly different. My goal is still to isolate x. So in this case, this is x over 7. So in order to isolate x, I'm going to go ahead and read it instead of over 7, I'm going to say x divided by 7. Why do I need to know that? Because in order to isolate it, I need to know the operation so I can do the inverse. I'm going to go ahead and multiply both sides by 7. This is applying the multiplicative inverse. Why am I doing this? Because it's going to create a 1 for me. By creating a 1, 1 times x is just x, which is going to isolate it for me, which is exactly what I need. So x is greater than or equal to negative 8 times 7 is a negative 56. So here, I'm going to go ahead and first just draw an open circle. Because it's greater than, I'm going to go ahead and draw it to the right. But because it's also equal to, I'm going to now go ahead and fill it in. So, again, notice the key thing is you need to make sure you're drawing an arrow to indicate that it goes on forever. And it's also, you need to understand that this basically represents any value greater than negative 56 will create a true statement, including number negative 56 as well. Okay, so for number 4, here we have 5k is less than 30. So since this means 5 times k, I'm going to go ahead and divide both sides by 5. I'm applying the multiplicative inverse. Why? Because it's going to create a 1, which is exactly what I need to isolate k. So here, k is going to be less than 6. To graph this, I'm going to go ahead and use 0 and 6. First, starting with an open circle, and because it says less than, I'm going to go ahead and draw an arrow to the left. Now, because it doesn't say equal to, I'm going to go ahead and leave it open. Okay, so now moving on. So first, let's go over some background knowledge. Here, when I was solving equations, I would, get rid of the constant by using the additive inverse to create 0, leaving me with 3x equals 12. I would get rid of the coefficient by dividing both sides by 3. That's applying the multiplicative inverse to create a 1, leaving me with x equals 4. Now here, there is only one solution. Okay, but now what if I have the same exact problem? However, it's an inequality. Well, notice the steps are going to be exactly the same. So here you're going to have 3x is greater than 12. Divide both sides by 3, and I'm going to be left with x is greater than 4. Now in this case, I don't just have one solution. There are plenty of numbers greater than 4, including 5, 6, 7, 8, 9, 10. You could have included 4.5, 4.5, 4 3/4, etc. So in this case, there isn't one solution. In fact, there are many solutions. So that's the main difference between an equation and an inequality. Now for number 5, this is basically a multi-step inequality. So first, we're going to go ahead and understand it is easier to undo addition or subtraction first. So I'm going to go ahead and get rid of this constant by doing the additive inverse of plus 5, which is minus 5. This is perfect because it's going to create a 0, and that's what I need, leaving me with 2m is greater than 14. Now, since this means 2 times m, I'm going to go ahead and do the multiplicative inverse, which is to divide both sides by 2. Why am I doing this? It's going to create a 1, which is going to isolate my m. So m is greater than 7. Now that I have that, I'm going to go ahead and graph it using, again, all we need is just a 0 and the value that they're referring to, which in this case is a 7. First, I'm going to start with an open circle. Since it's greater than, I'm going to go ahead and draw my arrow to the right. And that's it. Now, if there was an equal symbol, I would go ahead and take that extra step of filling in the circle. But because it doesn't, that's all I need. So, what are some values greater than 7? That's going to include 8, 9, 10, 11, 12, etc. It's also going to include numbers such as 7.2, 7 1/3, etc. It's going to include all the numbers in between as well. Now, is 7 included? No, because if it did, it would have the equal sign and we would fill that in. So remember that. Okay, so at this point, why don't you pause the video and try number 6 by yourself. Okay, so for number 6, first things first, we're going to undo this -6 by adding 6 to both sides. That's using the additive inverse property, which is going to create zeros. That's perfect because it gets us closer to isolating our variable. So we have 14x is less than or equal to a negative, let's do some side work, 34 and 6, find the difference, which is a 28. Now we're not done. This is 14 times x. I'm going to apply the multiplicative inverse by dividing both sides by 14. Why am I doing that? That's going to create a 1, which is exactly what I need, leaving me with x is less than or equal to a negative 2. Now we're going to go ahead and put that on a number line. First, I'm always starting with an open circle. We're going to go ahead and say x is less than or equal to negative 2, so less than is going to go ahead and go to the left. But because it includes the equal to, we're going to include the negative 2 by filling it in. And there you have it. Now, one tip that I want to give you when you're doing the homework is make sure that you're putting the dots in the line and not dragging. If you put a point and you drag it to the direction that you need, My Open Math really doesn't like that and it might mark you wrong. So if you're facing some difficulties of it getting marked wrong when it looks correct, try placing the points first and then connecting them afterwards. Okay, so for number 7, let's go ahead and try this one together. First, we're going to undo this subtraction. So instead of subtracting 7, we're going to add 7 by using the additive inverse. Creating m over 3 is less than 30. Now we're not quite done with isolating m, so here we're going to use the multiplicative inverse. Since this is m divided by 3, we're going to go ahead and do the inverse, which is to multiply both sides by 3. Notice I do like to write 3 over 1 so I can see that they cross cancel. Here we're just going to go ahead and multiply by 3, leaving me with m is less than 90. So starting with a number line, I'm going to go ahead and first just start with an open dot. Since it's less than 90, I'm going to go ahead and just draw my line with an arrow to the left. And it's important that you actually put an arrow. You don't want to just put a circle and draw a line. That is incorrect. You need to show that it's continuing on until infinity towards the negative. Number 8. So here, what am I going to do first? I'm going to go ahead and undo this 9 by subtracting 9 using the additive inverse, leaving me with w over 4 is greater than or equal to negative 21. Now, since this is w divided by 4, I'm going to do the inverse by multiplying both sides by 4. In this case, since it's a fraction, I kind of do like to put it as 4 over 1 to see that they cross cancel. So now that's going to leave me with w is greater than or equal to negative 84. So starting with the number line, first I always start with the open dot. W is greater than, so that's going to point to the right. Make sure you don't forget the arrow. But because it's also equal to, I'm going to go ahead and fill that in. So it's important that you understand in order for W to be a true statement, you need to W needs to be a negative 84 or anything greater than that. So negative 83, negative 82, negative 82.5, negative 82.6, all of those numbers in between are also included. So please don't think that it's just going to be a whole number. Well, guess what? That actually concludes the lesson for today. Thank you so much for tuning in. And as always, until next time, bye.